right. And I will share my ConveyLogix program. So with the ConveyLogix program, when you first open the software, comes up blank. And what you would want to do is start a new project, type in the IP address of the module, select which module it is. So ours is ConveyLinks, and enter the IP address and press OK. So here you can see mine under controller logic properties, the IP address of the module and its ConveyLinks. When you create the module, under tags, you drop down controller tags. Here you see all of the preset controller tags, inputs, all the sensor port inputs, sensor detect. I don't know why they didn't write in heartbeat on 15. So here's all the inputs, outputs, running motors, direction for the motors, turning on control port outputs, and then enabling digital mode, turning on the motor windings, and then using the brake pin. From upstream state or the upstream module status, tracking from the upstream module, state or status from the downstream module, status 2, the upstream module, status 2, the downstream module, 2 downstream tracking, motor speed, sensor polarity, and then some servo stuff, servo set points, resets, and go commands. Notice how, for example, like inputs, you don't see motor current or frequency. Those are still available. We just have to use an instruction to get them. I'm not sure why, but they did not make the controller tags all inclusive of everything available. I kind of question that, but really not much I can do about it. We also have here, and by default, this is just an integer. These are controller tags. But as you can see, because they're white, we can use these. They're not preset. And what these are for, in Allen Bradley, have you used produce and consume tags before? That's what these are for. These are used to set a tag as being produced to an IP address or consuming data from an IP address. Once you select to actually use it as produce or consume, there are a few preset registers to read from, or you could select specific register numbers and you would get what numbers from the documentation up here in the inputs register. If I wanted to read the right current from another card, I would read register 79. So that's what these are used for. The good thing is we are not Allen Bradley. Allen Bradley, if one card is a producer or one processor is a producer, you have to configure the other one to be a consumer. Vice versa. You don't have to do that with our product. I could tell this module to produce and consume to 4 other modules because I have 4 tags, and those other modules would just accept the data or give up the data without any further programming required. Main routine. And you're going to see things very, very similar to the Allen Bradley programming. First ladder, set the first scan. This one's a little different. We'll talk about this later. This is like the left and right motor status. Because that's not a regular tag, we have to use a module specific instruction, read, RDR, read register. What register are we reading? 58. And I name the tag left status because this is where the left motor status is. 82, the right motor status. Is that correct? Is it 82 or 88? Right motor status is 82. Okay. Read the current for the right motor. So these were just some basic things that I grabbed just as an example. 2, PLC array, we'll talk about those last. From upstream state, from downstream state, zone status. These are integers now. They're not high byte, low byte, add-on instruction does logic for us. So we have to actually mask out the high byte, 0, 0 on the reverse stuff. I want the low byte, which is the forward status. Upstream photo eye timing. Downstream photo eye timing. In our case, because it's real small, we'll keep it 10 and 100 for now. And now that I have all my inputs, first scan, grab inputs, first scan, jump. So I jump over the logic to the label. Notice how on our label, no logic after the label. Allen Bradley, you have to have logic. First scan timer. We'll make 5 seconds, just like in the Allen Bradley. In this one, when I'm in my first scan timing, this is where I'm moving the status 6. In our Allen Bradley example, I had an extra branch here. But as you can see here, I've jumped over this part of it, and I just do it right here. The motors, first scan timer's timing, eyes aren't blocked, run the motors. Left if I'm accepting or moving upstream to downstream. The right motor if I'm moving from upstream to downstream, or I'm discharging. Here I added an extra little bit, which would just make the left motor turn off a little faster. And then, of course, the zone status. I'm not doing the tracking stuff here, but it would be the same. It would be the exact same as this Allen Bradley. You'd have to grab your tracking data, move it to a temp register or a permanent register, then move it to the right eye, and so on. In this convey logics example, I'm just not doing the tracking part, just kind of make it simple. So this right here would be your basic program. We have the verify button. And the output window down here says no errors. I'm only using 10% of the tag capability in this processor. This is the make a bin file. So you can make a bin file, which then makes this accessible. You can download the program with Easy Roll. See the little asterisk letting us know we've made a change. So we need to make sure we save it. We can't download a program with an active edit. And so now we can. And I'm gonna go to our Allen Bradley program. I'm going to go offline. File, save as, ZPA module, and convey logics, which means we no longer need PLC mode, which means we don't need the PLC mode add-on instruction, and we do no longer need the PLC mode module. Save it. And download it. Well, that's working. I will, just so you can see that it kind of works the same.
Mm-hmm.
I will go ahead and just grab the tracking one time. So we would copy, paste, right click, edit, not equal, bit, one shot. And here you double click and we'll just write tracking underscore one shot. And then all I did was click out of the box. That automatically knows this is going to be a Boolean. And we will then move input, not one of my tags, but a controller tag from upstream tracking. We'll call this, just double click in it. Here we go. Tracking from upstream. We'll just call it that for now. Dent, yes. And to read the tracking data is the same instructions. So it'll be math, divide, move, mask move. Divide 16 pound, 1, 2, 3, 1, 1, 2, 3, 4, enter. And mask move 16 pound, 1, 2, 3, 4, 1, 2, 3, 4, enter. Destination. With Allen Bradley, when we were doing the divide and multiply, that was our sequence number. And when we did the mask move, that was our location. In convey logics, the order of the information, the two registers are swapped. Why? I don't know. But knowing that ahead of time, it's okay. So that means this tag is actually the divert location, not the sequence number. And this one, double click in it, is actually the sequence number. Verify our program, mainly to make sure I didn't make a masking mistake here. No errors. Excellent. Save. And we will download. Like anything on the conveyor, I should do. So I cleared everything off the conveyor, and this means go online. And my eyes are clear, and that's what I have. Perfect. So that's correct. Excuse me. As you can see, now that we're online, we get, although these rungs don't change color, instructions and values now turn green, indicating we are online. Some things about being online. So, yes, you can observe all your logic, watch it run, and find your bugs, find your issues. Number one, right click. There is no edit the run. So you cannot edit logic live. If you see you made a logic error, you have to go offline, correct your error, save, and download. Number two, values and variables, like zone status, for example. Yes, you can change these live. So went to 6, back to 4. Timer values, 200. So you can change the value of variables. But this again is for debugging purposes. So my timers, I'm running, I'm fine tuning. And let's say this is my final state. This is perfect. Okay, 200 for the downstream clear timer. You got to go offline, change it to 200, and then download.
Gotcha.
The reason is, yes, you changed it live, and yes, it is changed live. But the problem is, when they power cycle the module, when it powers up, it's going to retrieve what was downloaded. And we downloaded 100 milliseconds, not the edited 200. So that's why you go offline, correct your logic, correct your timer values, save it, and download again.
Okay.
But the biggest part, as you can see, this is Allen Bradley ladder logic. There's no difference.
Gotcha.
We'll have people say, "Oh, you're developer guys. Oh, they just copied Allen Bradley and made PLC stuff because they did Allen Bradley programming." No. Before our developers, industrial software, they're located in Sofia, Bulgaria. Before they started down the material handling world and working with conveyor controllers, their main job was to make PLCs.
Oh, okay.
So doing this right here was like something really simple for them to do.
Gotcha.
But unfortunately, because of the capabilities of the processor on the card, things like online edits, changing values, things like that just, are not permanent.
Gotcha.
So knowing this, we work within our limitations. Once you have your program and once it is downloaded, the thing you would want to do is look up here at the top, this last part. Task time, less than a millisecond. That's equal to Allen Bradley's scan rate. So the scan rate of this program running internally on the card is less than a millisecond.
Okay.
So this is actually screening pretty good internally. The CPU usage. This one's the one that's important. When you're online and the program's running and the motors are running off and on, they're turning on and off, you want to look at CPU usage. As long as you're 85% or less, preferably even less, 68% is kind of up there. but you want your percentage of the CPU usage, you want it to be 85% or less. I've seen some programs get close to 90%. It's kind of pushing it. And what we worry about on the CPU usage is when you get too high, the processor is running this ConveyLogix program instead of also being concerned about communications to other cards or properly running motors. It interferes with other tasks of the processor. So that's why we want to make sure the CPU usage doesn't get extremely high.
Gotcha.
And what I will do now, I'm going to go ahead and open here. I'm going to put my Rockwell over here on a, I'm going to go see, save the Rockwell. Let me download it. I don't know if I downloaded it or not. So we'll download, getting rid of node 2. And what I'm going to do to make things easy, we had blocked one zone there so we can retain our logic. Guess I should show. So here's the program. Write tracking.
Mm-hmm.
So let's write sequence 7, location 77, enter. We'll look at ConveyLogix. What I actually did was go ahead and I blocked the downstream sensor. So that way we wouldn't have to worry about a load leaving from the upstream here. And so we'll go back to Allen Bradley. So we're at 393. I guess I should put a load onto there. Now we have an arrival. So it's arrival 8. So we'll make it 888 and release the load. And nothing happened. Oh, why not? Well, let's check ConveyLogix. Well, I'm online, and from upstream status is a 5. Well, why isn't it giving me a what am I telling upstream? Did I make a programming error? Oh, look at that. And down here, I'm using the wrong states of the sensors. These were different photo eyes.
Mm.
So what we have to do is go offline. And what we should be using is upstream, 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 upstream. I'm holding the tag with my left finger, and I'm using the scroll button to scroll this down. In Allen Bradley, you could just take the tag and hold it down here, and it would auto scroll. With ConveyLogix, you have to use the scroll wheel. So not blocked, not running, not blocked running, blocked running, not blocked running. Save, download. And I don't know if you could hear everything behind us, but because I had told the ZPA load to release, it did. And here we have tracking data. Then we have divert location 88 and sequence number 8. And so, although this is a different software, You program it basically exactly the same type of logic, same type of instructions, and you get the same type of results.
Mm-hmm.
Things that I said we would go back to. Here is a controller tag. It's called my IP address. Tags controller my IP address. And you can look at this in any binary, octal, decimal, hex, or even as an IP address.
Mm-hmm.
192.168.185.21.
Mm.
So here's the IP address. So this is called verify the local IP address. So with these two instructions, I retrieve the fourth octet out of the IP address, .21. And where this comes in handy is in the PLC. When you're writing your tracking data, of course, the sequence number will auto-generate, but the divert location would be predetermined, just like before, lane 5, lane 6, etc. But instead of saying lane 5, lane 6, you would give the fourth octet of the module where the load diverts. So this module here is at a divert location.
Mm-hmm.
And I check what's my fourth octet down here. Divert location would actually be fourth octet. And if this was location 21, and since my fourth octet is 21, that would mean divert.
Mm-hmm.
Well, if that's the case, then why didn't you just hard code it as 21 and be done with it? Well, I could have done that and made it kind of really super simple. But because I added this one rung of logic and everything else is all basic, nothing else is super specific, two upstream, two downstream. It can be any upstream, downstream, as long as it's my neighbors. What this ends up allowing us to do is with this one convey logics program, download it to every divert.
Mm.
But it's the exact same program. Yes, but it's not the exact same fourth octet. And this is a way to use one program on 20 diverts and be done with it. You don't have to go in and each program has to be hard coded for the specific value.
Yeah.
So that's just like an extra little feature that can be done. To PLC array in the controller tags, we have from PLC array. Up here says from PLC. This is a legacy tag. Do not use this tag if you're going to do this option. We would use from PLC array, and we would use, where is it? To PLC array. These are 16 integers each. And here I'm sending the status of the left motor. I'm putting it in array 1. And the status of the right motor, I'm putting it in array 2. Now what happens is, in Allen Bradley, and we can do this. I'm going to go do this now. We're going to go offline, right click, new module, Insight. integer. Under the options, convey logics. Okay, close, save, download. Now, what this does is give the PLC and the convey logics program an outlet to handshake data. So in the convey logics, the tag that says to PLC array, let me see which ones am I using. I'm using arrays 1 and 2. So let's do this. So array 3, array 4, and let's go to array 10. We'll put in a 10. Enter. So we have 3, 4, and 10 in their respective locations. In the Allen Bradley project program, we're going to go find convey logics, inputs. So these are, to PLC array are outputs from convey logics, and we read them as inputs from convey logics. Monitor. Where's my convey logics go? Array 3, value 3. Array 4, value 4. Array 10, value 10. This is a way to handshake data. So although the convey logics program is running all the programming to make it quicker, without all the latency of a PLC going back and forth, you can still handshake data. The convey logics program can still give you motor status, current draws. In the outputs, there could be something like, you could say output data 0. You could say this is, jog left. And you could say this one is jog right. So that's data 0, 0, and 1. If I go to convey logics, go offline, and say from PLC, and 0 was run left, and this one was run right, I could go to my logic, and here's just extend the branch. Controller tags from PLC array, data 0, bit 0, run left, right click copy, right click paste, from array 0, run right, save, download. Go online. And in the Rockwell program, if I say 1, enter, I don't know if you can hear it, but you can see here the left motor is actually running, drawing current. So if I turn this one off, we'll see the current draw go to 0. Left motor, force run. There's the current draw. Turn it off. Motor stops. So these 2 from PLC array tags, again, optional, but it's a way to have a ConveyLogix program running locally on the card, take some of the burden out of the PLC. But if need be, you could still handshake data, through these ConveyLogix tags. You get 16 integers of inputs from the card, and you can write up to 16 integers back to the card.
Nice.
Is there anything that is pre-assigned? No, nothing is pre-assigned for these tags. They have absolutely no meaning until you give them meaning.
Gotcha.
So here you can see ConveyLogix, although, Alan Bradley, whoa, that's big, probably has 10,000 instructions, of which I may know how to use 100 of them.
Right.
I don't know how to use all the instructions because it's pretty much for every industry. When it comes to our product and material handling, yeah, I'm a pretty good programmer. I'll admit that, especially with our product.
Right.
But once I step out of that scope, yeah, I could I do it? Yes, I have before,
Right.
but doesn't come as natural and as easily as our product.
Gotcha.
This is what I'm paid to know. So yeah, so it's not that I think I'm not only being paid to know the product, but I'm being paid to demonstrate how easy it is to use.
Gotcha.
Even making a mistake. Oh, here's a mistake. How do we fix it? Oh, here's how you fix it. Sometimes they're legitimate mistakes. Sometimes I do it on purpose. Just to kind of, we made a mistake. How do we correct it? I try to make it look simple. I don't want it to look too difficult, scare somebody away. That's my fear of scaring someone away because I made it look too difficult. But as long as with the ConveyLogix, as long as you're comfortable with Alan Bradley, you can be comfortable with this. With that said, as far as the normal stuff, the routine, that this would be a conclusion.
Yep.
But if there are things, I need to know this, or you forgot to mention that, please let me know.
Okay. Yeah, the only thing, just give me the access to those when I videos upload. But other than that, Tim, yeah, I think that you answer all of my questions, and I'll get these recordings over to the guys, and we'll review it. And they'll have proper training that they can reference. I mean, you pretty much covered every detail, and if there's a misalignment, I'm sure we could read the manual and maybe reach out if we don't have an understanding. But for the most part, it'd be good to go.
Okay, when the time comes, again, if you're able to, sometimes companies are restrictive on things, but if you can share your Alan Bradley program.
Oh yeah, sure. I
will definitely take a look at it, make suggestions. If I have free time, because I love the program, I could start working on it myself. No guarantees, but
yeah, I'm sure we'll have some hiccup somewhere where we need to control something, or auto configured and work correct. I'm sure we'll have those types of questions for sure in the future. And like I said, moving forward, we would try to reach out to postal or tech support and see if we get a hold of you.
Yeah, anyone that picks up a phone, answers a chat request or an email, is knowledgeable to help you. It doesn't have to be me.
Okay, sounds good.
All right, then, Taylor, it was nice to meet you.
Yep, I've enjoyed
it. Have a great afternoon. I'm going to go ahead and stop the recording now.
Okay.